In this episode, we focus on a skill that separates reactive security from proactive security, the ability to quickly determine your attack surface, meaning the set of places an attacker could realistically touch, influence, or exploit. Beginners often imagine attack surface as only internet-facing servers, but the real concept is broader and more practical. Attack surface includes exposed services, risky integrations, over-permissioned identities, fragile data flows, and even code paths that handle untrusted input. The reason SecurityX cares about doing this fast is that security teams and leaders are constantly asked to make decisions under time pressure, like evaluating a new system, responding to a suspected incident, or approving a vendor integration. If you cannot identify attack surface quickly, you will either miss major risks or waste time defending low-impact areas. This episode is about speed with discipline, not speed with guessing. We will learn how trust boundaries help you spot where risk concentrates, how data flows reveal hidden exposure, how code review thinking surfaces weaknesses, and how discovery practices keep you from relying on outdated assumptions. By the end, you should be able to walk through a scenario and map the likely entry points and weak links in your head in a way that leads to clear priorities. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Attack surface is easiest to grasp when you think in terms of touch points, meaning any place where something outside a trusted zone can interact with something inside a trusted zone. That outside something might be a person, a device, a third-party service, an API call, an email attachment, or an automated process. The inside something might be a database, an identity system, a management interface, a business application, or a sensitive workflow like payment processing. Every touch point is an opportunity for misuse, and that is why attack surface grows as systems become more connected. Beginners sometimes treat connectivity as purely a productivity benefit, but connectivity also creates paths for attackers. Your goal is not to eliminate all touch points, because the business needs them, but to identify which touch points matter most so you can protect them with the right controls. Doing this fast means you prioritize visibility first. You want to know what exists, how it connects, who can access it, and what data moves across it. SecurityX exam scenarios often describe systems with multiple integrations or rapid changes, and the best answers usually begin with identifying exposure points rather than jumping straight to a specific tool or control. Trust boundaries are one of the fastest ways to organize attack surface, because they define where you stop trusting by default and start verifying. A trust boundary is the line between components that operate under different assumptions of trust, such as between the public internet and an internal network, between a user device and a server, between a third-party service and your environment, or between one internal network segment and another. Beginners often assume the boundary is the firewall, but modern systems have many boundaries, including application-level boundaries, identity boundaries, and data boundaries. The value of identifying trust boundaries is that attackers often target boundary crossings, because that is where inputs enter, privileges change, and validation can fail. For example, if a public-facing API crosses into a database, that boundary is a high-value point. If a vendor integration crosses into your internal systems, that boundary is a high-value point. If a user login crosses into an administrative role, that boundary is a high-value point. SecurityX expects you to recognize that boundaries are where you need stronger controls, such as authentication, authorization, input validation, logging, and segmentation. When you can spot boundaries quickly, you can spot where the attack surface is concentrated. A practical way to find trust boundaries quickly is to ask where identities change and where permissions expand, because those are common boundary moments. When a user logs in, the system shifts from anonymous to authenticated, and that is a boundary crossing. When a normal user becomes an administrator, privilege elevates, and that is a boundary crossing. When a service account accesses a database, the access rights and data sensitivity may increase, which is another boundary crossing. When a developer pipeline pushes code into production, the boundary between build systems and production is crossed, and that can be exploited if controls are weak. Beginners often focus on network edges, but identity and privilege boundaries are often more important because so many attacks involve credential abuse rather than deep technical exploits. SecurityX scenarios frequently include hints like shared credentials, over-permissioned accounts, or vendor access, and those are all identity boundary problems. If you train yourself to look for where identity and privilege change, you will identify high-risk surfaces faster than if you only look for open ports. This is also why least privilege and separation of duties are repeatedly tested, because they shrink the blast radius when a boundary is crossed. Data flows are the next fast method because data movement reveals exposure that asset inventories alone can miss. A data flow is simply the path data takes from one place to another, such as from a user browser to an API, from an API to a database, from a database to analytics, or from production to a test environment. Every flow creates at least two risks: interception or manipulation during movement, and unauthorized access or leakage at the endpoints. Beginners often think data is stationary, but modern systems copy data for backups, caching, logging, search indexing, and integrations, meaning the same sensitive data can exist in many more places than the primary database. When you trace data flows, you often discover hidden attack surface, like an export process that writes sensitive data to a file share, or a logging pipeline that captures personal data, or an integration that sends data to a vendor's system. SecurityX scenarios sometimes describe a leak that occurred not from the main database, but from an overlooked copy in a staging environment or a report stored in an unprotected location. Data flow thinking helps you see how that happens and helps you prioritize controls like encryption in transit, access control at endpoints, and minimization of unnecessary copies. When determining attack surface quickly, it is also important to understand trust boundaries around data classification, because not all data flows are equally risky. A flow that carries public data is lower risk than a flow that carries sensitive personal data or authentication secrets. A flow that carries internal operational data might be moderate risk, while a flow that carries privileged access tokens is high risk even if the volume is small. Beginners sometimes focus on volume, assuming big data flows are the main concern, but small flows can be more dangerous when they carry high-power secrets. This is why a fast attack surface assessment should include asking what data type flows across the boundary and what would happen if it were exposed or altered. If the flow carries credentials or session tokens, it can become an identity compromise pathway. If it carries financial data, it can enable fraud. If it carries health information, it can trigger serious privacy obligations. SecurityX tends to reward this nuance because it shows you prioritize based on impact, not just based on what looks busy. When you combine data flow mapping with classification, you can decide which flows need stronger protections first. Code review thinking matters because much of the attack surface lives inside application logic, not just in infrastructure exposure. A code review, at a high level, is the practice of examining how software handles inputs, enforces authorization, manages errors, and interacts with sensitive resources. Beginners sometimes think code review is a developer-only activity, but from a security perspective, code review is an attack surface discovery tool because it reveals where untrusted input enters and what the application does with it. The fastest security-oriented code review mindset is to look for dangerous patterns, inputs that are used without validation, authorization checks that are missing or inconsistent, secrets that are embedded in code or configuration, and error handling that reveals too much information. You also look for logic that could be abused, like workflows that allow account takeover, password reset paths that can be manipulated, or APIs that expose more data than intended. SecurityX may not ask you to read code, but it will ask you to reason about how code creates risk, particularly around authentication, authorization, input handling, and data exposure. When you learn to think like a reviewer, you can identify attack surface even when the network looks locked down, because the application itself may be the open door. Code reviews also connect back to trust boundaries and data flows, because code often defines the boundaries that networks can no longer enforce. In modern architectures, services talk to each other through APIs, and network controls alone cannot always ensure that only authorized requests are made. The application must enforce authorization and must validate that the caller is allowed to do what it is asking. A beginner mistake is assuming that if traffic is internal, it is automatically trusted, but internal traffic can be malicious if an attacker compromises one internal service or one internal account. This is why internal trust boundaries matter and why code must enforce checks even for requests that originate inside the environment. Code review thinking helps you spot where internal calls are treated as automatically safe and where sensitive actions can be triggered without proper verification. SecurityX scenarios may describe lateral movement or service-to-service compromise, and the best answers often involve limiting trust between services, enforcing authorization consistently, and monitoring for unusual internal requests. When you connect code review to boundary thinking, attack surface becomes visible not only at the perimeter but inside the architecture. Discovery is the final pillar, and it is about knowing what exists in reality rather than what the documentation says exists. Attack surface assessment fails when it is based on outdated diagrams or assumptions, because environments change constantly through new deployments, temporary test systems, vendor integrations, and forgotten services. Discovery means maintaining visibility into assets, services, and identities, including what is exposed, what is reachable, and what is running. Beginners often assume discovery is a one-time inventory task, but real attack surface management treats discovery as ongoing because drift is normal. For example, a staging server might be created for a quick project and left running with weak controls. A new API endpoint might be deployed without full review. A third-party integration might be granted broader permissions than intended and never revisited. Discovery practices help you find those surprises before attackers do. SecurityX questions often include the theme of unknown exposure, like an organization being compromised through an untracked system, and the correct response often includes improving asset inventory, continuous monitoring, and change governance so the program stays aware of what exists. Fast attack surface determination also benefits from a layered questioning approach that you can apply mentally during scenarios. You start with what is exposed to the outside, including public services, third-party access, and user-facing endpoints. Then you move to what connects internally, including service-to-service communication and shared identity systems. Then you focus on where sensitive data and high privilege exist, because those are high-impact targets. Finally, you ask what has changed recently, because new changes often introduce new exposure and new misconfigurations. This questioning approach is not a checklist to memorize. It is a way to stay oriented. It prevents you from missing the quiet paths that attackers love, such as internal management interfaces, overlooked integrations, and over-permissioned service accounts. SecurityX often tests whether you can identify the best starting point for analysis, and a strong answer often emphasizes understanding exposure, boundaries, and data flows before taking action. When you can do that quickly, you can prioritize the highest risk surfaces even when information is incomplete. Another crucial part of attack surface is human and process exposure, because people are often the interface attackers use to cross trust boundaries. Social engineering targets the human trust boundary, convincing someone to approve access, reset a password, or reveal information that enables an attack. Weak onboarding and offboarding processes can leave active accounts, creating attack surface through stale access. Poor vendor management can create attack surface through unmanaged third-party credentials. Beginners sometimes separate human risk from technical attack surface, but in practice they are connected because credentials and approvals are the keys that open technical doors. SecurityX scenarios frequently blend these factors, such as an attacker gaining access through a vendor account or a phishing message leading to privilege misuse. A fast and disciplined attack surface assessment, therefore, includes asking where decisions and approvals happen and how they can be abused. Controls like multi-factor authentication, least privilege, training, and access review are attack surface reduction controls because they reduce the number of successful boundary crossings an attacker can achieve through people. When you include the human layer, your assessment becomes more realistic and your control choices become more effective. As we wrap up, determining attack surface fast is the skill of quickly identifying where untrusted inputs can reach valuable assets, especially at trust boundaries and along data flows, and then prioritizing what to secure first. Trust boundaries help you locate high-risk crossing points where authentication, authorization, and validation must be strong. Data flows expose hidden copies and unexpected movement of sensitive information, revealing risks beyond the primary system. Code review thinking surfaces logic-level exposure, especially around untrusted inputs, authorization gaps, and secret handling, which often define modern attack surface more than network ports do. Discovery keeps the assessment grounded in reality by revealing what is actually deployed, exposed, and reachable, preventing drift from turning into blind spots. When you combine these lenses, you can identify likely entry points, understand how an attacker could move toward high-value targets, and choose controls that reduce exposure and limit blast radius. SecurityX rewards this approach because it demonstrates you can think like a security leader under time pressure. You find the real surfaces, you focus on the ones that matter, and you do not let complexity hide the obvious.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.